Hello guys, this is Trockers. Thank you so much for tuning in. Okay, we have a problem on ordinary differential equation. We are told that a mathematics teacher is going on vacation leave before his students write their final examination. He has tried to keep it a secret, but the rumor is already spreading in the school at the rate which is proportional to the product of the proportion x of those who have heard it and 1 minus x those who have not heard it. The situation is modeled by the differential equation dx dt is equal to kx 1 minus x. If initially a proportion c of the population has heard the rumor, show that x equal to c plus 1 minus c e to the negative kt. So this is exactly what we are trying to show. All right, guys, so what we need to do here is just to go straight into the solving of the equation since it has already been modeled for us. All right, so I'll go ahead. Okay. All right, so we are told that, okay, this is the final outcome. Allow me to put this here. So x equal to c over c plus 1 minus c e to the negative kt. This is what we are trying to show. So at the end of the day, we need this, right? We are given the differential equation dx dt equal to kx of 1 minus x. All right, so guys, every time when you have it in ODE like this, we need to know how to separate the variables. And when separating the variables, try to leave the constant on the other side. So I'll go ahead and separate the variables now. So I'm going to bring this down. It's x 1 minus x integral dx is equal to k integral of dt. Right, so this simplifies to 1x 1 minus x dx is equal to kt plus our integration constant c. Right, okay, so what we need to do now is to partialize this. So here, okay, so here we can let a over x plus b over 1 minus x be identical to 1 over x 1 minus x. So here it simplifies to this, right? Which is identical to 1 over x 1 minus x. So here we can equate the numerator here. So once we equate the numerators, we are going to let, we can let x is equal to 1. So when x is 1, this becomes a 0. So we have b equal to 1. When x equal to 0, when x is equal to 0, this one disappears. So a equal to 1, which implies that a over x plus b over 1 minus x is the same as saying 1 over x plus 1 over 1 minus x. So we are going to replace this side. We are going to replace this expression with these two expressions. So I will bring this down. All right, so now this implies that we have our integral of, it was 1 over x plus 1 over 1 minus x, right? Dx equal to kt plus c. Right, so here guys, when we're integrating, let me show you something. It's going to be integral of 1 over x dx plus integral of 1 over 1 minus x dx equal to kt plus c. Okay, so when we are integrating here, we are trying to use this concept. If we integrate a function of the form f of x, I mean first derivative over the function with respect to x, if we're integrating that, we should get natural log of function of x plus c. So this is what we are trying to have here. So if we differentiate 1 minus x, we are going to get -1. Hence, I'll put a negative and a negative outside. I did not change much. It's just that I manipulated the situation so that it conforms to this structure here, right? So when I differentiate now, I'll get natural log of x plus, this becomes minus natural log of 1 minus x, right? Equal to kt plus c. But remember, guys, this is what we are trying to get at the end of the day. We need to get x equal to c over this 1 minus c e to the negative kt. Okay, so now let's go back to our question. So coming back to our question here, we have this part. So what we are going to do is to combine this and such that we have natural log of x over 1 minus x equal to kt plus c. So remember, guys, when we simplify logarithms, we use, especially here, we are subtracting them. So we are going to use the quotient rule. So now let's go ahead and get rid of the ln, the natural log on both sides. So I will exponentiate here. If I raise everything to the power of e, right, it's gonna be, okay, so it's gonna be x over, okay, so I have x over 1 minus x equal to, here it is the same as saying e to the kt multiplied by e to the c, but this is just a constant, so you can say x over 1 minus x is equal to a e to the kt, right? But according to the question now, we are given these conditions. If we come back to the question, we are told that if initially a proportion C of the population has had the rumor, show that, right? Meaning to say, remember x at the rate which is proportional to the product of proportion x, those we've had, and 1 minus x, those we have not had it. So meaning to say, in this case, when x is C, t is 0. So if we come back to this now, because we need to find the value for that constant. So if we come back here, we have our conditions. These are our initial conditions. At time t is equal to 0, x is equal to what? X is equal to c. So now when I come here, I'm going to get c over 1 minus c is equal to a e to the 0. Right, a e to the what? A e to the 0, which is just our constant a. Okay, so when our constant a is like that, we are going to have x over 1 minus x, which is just a, is equal to c over 1 minus c e to the kt. So here I am going to cross multiply. Right, so when we cross multiply, we are going to have x 1 minus c is equal to c e to the kt 1 minus x. Right, so let's play around with this. If we distribute, you're going to get x minus xc equal to c e to the kt minus x, okay, minus x c e to the kt. Right, then remember, we are trying to show this. I can put it up here. We are trying to show that x is equal to c over, okay, let me write it here. So we are trying to show that x is equal to c over c plus 1 minus c e to the negative kt, right? So we also need to play around with the rules of logarithms. Okay, so from here, that's where we are trying to go, and we have this part here. So what I can do, I can bring everything that is to do with what? With x on the other side. So I can move this here, or I can bring this, yeah. So what I'm going to do is to move this, I'm going to keep it here. So I will have x minus xc plus xc e to the kt equal to c e to the kt, right? Then from here, I am going to take out x. So I'll take out x, and I'll have 1 minus c plus c e to the kt is equal to c e to the kt. We are almost there, guys. We are almost there. We are almost there because this is what we need. Then from there, I will divide. So x is equal to c e to the kt all over 1 minus c plus c e to the kt. But as you can see from here, as you can see, guys, it's 1 minus c e to the negative, and we don't have this exponent at the top. So if we play around with this very well, we are going to divide everything by c over kt, such by e to the kt, so that we have x is equal to, if we divide by that, it's going to be c, right? Okay, let me do it. C e to the kt, I'm going to divide by e to the kt, right? All over, this is going to be 1 over, right, minus c over plus c e to the kt over, so I'll divide everything by e to the kt, e to the kt, e to the kt, right? In the exam, you don't need to write like this, but in this case, I just want to show you how we are going to get the negative. So now it's x. Okay, so now it's x equal to, this simplifies to c, and here, if we divide, remember this negative rule of exponents, right? If it's x to the negative exponent, you just take the reciprocal with the positive exponent, okay? So now it becomes e to the negative kt, then here minus c e to the negative kt, then here plus c. So I can play around, I can move these, okay? I can just switch these terms here. Sorry. Okay, so if I move this up, I am going to get, sorry, it was this one. Oh my God, I'm sorry. Okay, so this one was, okay, after I write. Okay, no problem. Okay, so from here, when I divide, it's just plus c. Okay, let me move this up. All right, so from there, I can play around with these terms so that I have c plus e to the negative kt minus c minus e to the negative kt, right? Then I can take out c, because coming back to the question, we need to show that it's c, everything it is, okay, it's c over that. Okay, so coming back to our problem here, we are going to have c over, right? I can keep this c here, right? So I can keep this c up here for a second. Okay, let me go back to the question. Okay, yeah. So I'm going to keep this c here. Then I'm going to move e to the negative kt. Let me see, just 1 second. I think I made a mistake somewhere here. I know I don't have a c here, so this is just e to the negative kt. All right, cool. So with this one here, it's e to the ce. Yeah, that's where I made a mistake. This was just e to the negative kt, so I don't have this c up here. All right. So I moved this c, so plus e to the negative kt. All right, cool. Now we can go back and fix. All right, so at this point, I am going to take out this. So when I take out the e to the negative kt, I will remain with this, which is exactly what we wanted to show. Right, this is exactly what we wanted to show. All right, so guys, with this problem, you needed to play around with rules of exponents. Remember, we started off with this. We started off with this function here, right? All right, sorry. We started off with this function. They didn't suggest the method for us, but we needed to use the partial fractions, right? After using the partial fractions here, we had to simplify by applying the initial conditions here. On the question, they just said initially. So every time you see that, every time you see this initially, right? If you see this word initially in a statement, it means our time is what? Our time is 0, okay? Then from there, we played around with the terms until we get to this desired point here. We played around with that, sorry. Okay. We played around with that until we get to this desired point here, which is c over c plus 1 minus c e to the negative kt. So guys, let's continue to do more problems similar to this until we are ready for the exam. With that being said, I'm signing out. Thank you.